Hi, welcome to YouWillUnderstandMath.com. Right now, I want to show you a shortcut on how to fill in the unit circle, the cosine and sine values at each angle on the unit circle. I've shown you in a previous video how to find each cosine and sine value using 30, 60, 90, and 45, 45, 90 special right triangles. This time, I want to show you a shortcut. Let's get started. Notice this value, the square root of 4 over 2. The square root of 4 is 2, and if we bring the 2 over and divide, 2 divided by 2 is 1. This is a very important key for the unit circle. Notice here the square root of 1 is the same as 1, so the square root of 1 over 2 is the same as 1/2. In the same way, the square root of 0 is 0, therefore the square root of 0 over 2 is 0. Our cosine value of 0 or 2 pi would be the square root of 4 over 2. The cosine value of pi over 6 will be the square root of 3 over 2. The cosine value of pi over 4 will be the square root of 2 over 2. The cosine value of pi over 3 will be the square root of 1 over 2. The cosine value of pi over 2 will be the square root of 0 over 2. Did you see that pattern? 4, 3, 2, 1, 0. That's the whole key. Of course, we can reduce, as I did over here, so that the square root of 4 over 2 is 1. We would replace this with 1. The square root of 1 over 2 is 1/2. We can replace the square root of 1 over 2 with 1/2. The square root of 0 over 2 is 0. This would be 0, which looks very familiar on our unit circle. Notice the sine values. The sine values go in the opposite order. For example, we would start with the square root of 4 over 2 for the sine of pi over 2. The sine of pi over 3 would be the square root of 3 over 2. The key is knowing all of the cosine and sine values in the first quadrant. Knowing these values, you can always reflect across either the y-axis, this navy blue vertical line, or you can reflect a value across the x-axis to find values in the bottom quadrants. Here I've simplified all of the values using this information here. The square root of 4 over 2 is 1. So for example, where I had the square root of 4 over 2, I reduced it to 1, as well as here. The square root of 1 over 2 is 1/2. I simplified it here and here. And then the square root of 0 over 2 is 0. I put that here and here. Now I want to remind you of reflexivity. Notice here, I have the x and y axis as well as 4 points. I'll start here in the first quadrant. Remember that points in the first quadrant have positive x and positive y values. Points in the second quadrant have negative x values and positive y values. Points in the third quadrant have negative x values and negative y values. And points in the fourth quadrant have positive x values and negative y values. If I began with this point, 4, 3, meaning that the x value is 4 and the y value is 3. If I reflect this point across the y-axis, notice what happens. The x value becomes negative. The y value doesn't change. If I took this same point, 4, 3, and reflected it across the x-axis, the x values won't change, but the y value will. It will have the opposite sign. This is what I'm going to use to complete the unit circle. I know all of the values in the first quadrant. If I reflect any of these values across either the x-axis or the y-axis, I can figure out the other values. Notice if I reflect the cosine and sine values at pi over 3 across the y-axis, I can get the values in the second quadrant. If I reflect pi over 3 across the y-axis, I'll get the values for 2 pi over 3. Remember in the previous example, when I reflect a point in the first quadrant across the y-axis to the second quadrant, the x value changes its sign. It was positive in the first quadrant, now it's negative in the second quadrant. The y value keeps its sign, it doesn't change. If I wanted to reflect pi over 3 across the y-axis, then the value at 2 pi over 3 will be negative 1/2, and the y value will remain the same. It will still be positive square root of 3 over 2. I've completed all of the values in the second quadrant using the same notion. Notice all of the cosine values are now negative. The sine values are still positive. In order to find the values in the third quadrant, I may reflect values in the second quadrant across the x-axis. Remember what happens when I reflect a value in the second quadrant across the x-axis. The x value doesn't change, but the y value will change its sign. For example, if I reflected this point negative square root of 3 over 2 and 1/2 over the x-axis, the x value or the cosine value would still be negative square root of 3 over 2, but now the sine value will become negative. This will be negative 1/2. Completed the values in the third quadrant using the same notion. Okay, notice all of the cosine values are negative except 0. There's no such thing as a negative 0. And all of the sine values are negative. In order to find the values in the fourth quadrant, I can reflect values from the first quadrant or the third quadrant. It may be slightly easier to use the first quadrant. For example, if I wanted to find the value of 5 pi over 3, I can reflect the value of pi over 3. The x value or the cosine value will still be positive 1/2, but now the sine value will be negative because we're in the fourth quadrant. Same idea, I've completed the fourth quadrant. There you have it. Our unit circle is completely filled with all of the values, the radian measures, which you can convert into degrees if you like, as well as the cosine and sine values at each angle. Thank you for watching this video. Please like and or subscribe.